Assalamu alaikum students, I hope you all are doing great. In today's video, we will be solving the two hardest questions of A-level physics. One is this and I will show you the later. I will show you the second one later. Right? So I will share the variant of this paper in 3, 2, 1. As you can see the variant of this paper. So let's begin with this and let me make life simple and easier for you. Okay, we will do it with very simple and easy method. A student wishes to determine the density P of lead. This is density P of lead. She measured the mass and diameter of small sphere of lead. Mass is this, and we have given the diameter as 2.20 and 0.02 millimeter. What the best estimate of the percentage uncertainty in a calculated value of P? So we have to find the percentage uncertainty in density basically. So we have given mass and diameter. What is the formula for density? Density equals to mass over volume. We have given the absolute value for mass, the absolute uncertainty for mass, but we have not given volume, the values of volume. So, in order to find volume, we use diameter. We'll actually find volume in terms of diameter. Okay. So, what is the volume of sphere? Volume of sphere is 4 over 3 pi r cube, right? This is the formula for sphere. So let me drive it. Since we have given the diameter, so can we write radius as diameter upon 2, right? So this is 4 over 3 pi d upon 2, and this is power which is cube, right? So let me expand it here. 4 over 3 pi d multiplied by 3 is d cube, and 2 into 3 is 2, 2, 2, which is equals to 8, obviously. So this is 8. So 4 and 8 can be cancelled. 4 1 the 4, 4 2 the, sorry, yeah, 4 2 the 8. So we have d cube over 3 to the 6, d cube over 6 as our final answer, which is actually volume of sphere, right? In terms of diameter. All right, so we're gonna solve it now. The percentage uncertainty as delta D, delta rho over rho, and delta M over M plus. But when we're talking about diameter, we have power of diameter as 3, right? So how we gonna solve it? We're gonna multiply the whole delta D over D by 3 because we have power as 3. If we have 2 or we have square, you can say, so we will write 2 here. But in this case, we have cube, so we will write the power here and then multiply by bracket, right? So 3 is the power, and we will write delta D over D. This is basically volume, right? You can also write it as volume, but here we have given diameter, so we are taking the values in terms of diameter. We don't need to change the units since we are calculating percentage uncertainty. So delta rho over rho, we don't know the value, we have to find it, and equals to what is delta M. So we have delta M over M. We will write diameter as 3 because we have power of 3, right? So 3 multiply by delta D over D. This is our diameter formula. So this is delta rho over rho. We will put the values. 0.005 over the final value of m is 0.506. You can see here 0.506 plus 3 multiply by 0.02 divide by 2.20. This is diameter. By the way, this value is absolute value and this is absolute uncertainty. So we will write uncertainty first and then jot down absolute value. So we will multiply the whole thing by 100. Why? Because we have to find percentage uncertainty. Let me calculate the final answer here. Here we have the actual answer, which is equals to 3.71 percentage. So you will write as 3.7%, right? Where it is written B, C, D. Yes, D is our right answer, right? So that's how we calculated this percentage uncertainty. Most of the students find it difficult, but when you see this, you will say, oh, it was easy, right? Let's move to another question. You can see the variant in 3, 2, 1. This is the variant for this question. Let's solve this one. It is related to, you can say, accuracy and precision. The previous one was about errors and uncertainties. Solving this question here. Four different students use ruler to measure the length of 15 centimeter pencil. Their measurements are recorded on four different charts. These are the four different charts. Which chart shows measurements that are precise? Remember the keyword. That are precise but not accurate. So let me tell you one thing. What is mean by precision? It, you can say, precision is the consistent value, right? Precision means the consistent value. While what is mean by accuracy? Accuracy means accuracy means the closest value you can ever have, or the closest possible value. These are the two definitions of accuracy and precision, right? So precision means the consistent value. Oh, there's typo, but you can ignore it. Precision means consistent value. Accuracy means closest value. For example, if we have values like 9.8, 9.6, 9.4, and 9.5, and we have the actual value of 10.0. These values are not much accurate, but they are precise as they have difference of 0.2, 0.2, 0.1, 0.1 to 0.2 difference. So they are precise value, but they are not much accurate. Similarly, if I give you example of the same thing, our actual value is 10.0 and we are getting answers at 9.6, 9.9, 9.8 again, and 10.0. These all values are precise but accurate as well, right? Because they are closest possible to the answers. I hope you understand this. Now solve the question. The actual value here is 15. Let me mark it here. 15, 15, 15 as written in question. So we have to analyze all these dots, or you can say all these points. which are precise but not accurate. It means they are not closer to the actual answer. So we have 15 here, point it is accurate, but we have to find not accurate. Okay, then see 14.6, approximately 14.5, 14.4, and 14. The difference between 14 and 14.4 is of 0.4. And then the difference between 14.4 and 14.5 is 14, if of it is of 0.1, right? And here is 15. These values are not in the same line. These are not like this, right? So these are not precise, although they are accurate enough, you can say. A is incorrect. Let's talk about B. Here is 14. Here is 14.2. Here is 14.3. This dot, and this is 14.4. Also, one thing, it is not necessary that a value have to accurate and precise. A value can be precise, but it not necessary can be accurate, right? So he's talking about precise but not accurate. We don't need the accuracy. So 14, the difference between 14 and 14.2 is of 0.2, 14.2 and 14.3.1, and 14.3 and 14.4 is 0.1. So as you can see that these all values are precise but not accurate. Because if they are accurate, they should be here 14.8 or 15.1, right? These are precise. Let's talk about C and D. Here we have 14.4 and there's a great difference. 15 minus 14.2, 0.8 difference. There's too much difference. And again, they are going upwards, so they are not precise. They are not consistent actually. Let's talk about D. This seems to be consistent. There is 14.8, 15, 15.2, and 15.3, right? But you can see they are going above our actual value, 15.2. Also, there's a difference between 14.8 and 15.2. 15.2 minus 14.8, 0.4 difference is too much. The difference between you can say 14.8 and 15.2 is larger. So they are not precise as well. But you can say they are accurate. So D is also correct because we have to find precise but not accurate. So what is the best answer fitting in this condition? It is B because B is precise and not accurate. As you can see, the values are not closer to 15, but they are closer to each other, which means they are precise. Got it? So that was the whole concept. I hope you understand. Thanks for watching. I will catch you guys in the next video. Till then, love is take care.